If you've wired up Azure AI Search and Azure OpenAI and your document question and answer app still hallucinates or returns garbage, the problem is almost never the language model. It's the retrieval. In the next 5 minutes, we're going to take Retrieval Augmented Generation, RAG, apart end to end. You'll see the mental model, how the pieces actually wire together in Python, the 4 settings that decide whether retrieval works, and the production gotchas that quietly wreck answer quality. No feature tour, just the mechanism. Here's the model to hold in your head. A language model only knows what's in its training data and what you put in the prompt. RAG is just dynamically stuffing the prompt with the right snippets from your own documents at query time. So the flow is, take the user's question, find the most relevant chunks of text from your corpus, paste them into the prompt as grounding context, and ask the model to answer using only that context. Azure AI Search is the find step. Azure OpenAI is the answer step. Everything that matters lives in how well that find step works. Concretely, there are 2 phases. Ingestion happens once, or whenever documents change, you pull files from blob storage, split them into chunks, call the embeddings model to turn each chunk into a vector, and push the text plus vector into an Azure AI Search index. Query time is the live path. The user's question gets embedded. AI Search runs a vector and keyword search, and the top results plus the question go to the chat model. Notice the embedding model is used in both phases, and it must be the exact same model, or your vectors won't be comparable. This is where most people lose. Chunk size is a real trade-off. Too large and you bury the relevant sentence in noise and blow your token budget. Too small and you fragment the meaning. A common starting point is around 500 tokens per chunk with a 10 to 15% overlap, so sentences aren't cut mid-thought. But you should tune this to your documents. For embeddings, text embedding 3 small is cheap and strong. The large variant gives more accuracy at higher cost and dimension. Store the source file name and a page or section reference alongside every chunk. You'll need that metadata for citations and for debugging why a bad chunk got retrieved. A pure vector search feels magical until someone searches for an exact product code or an acronym, and semantic similarity sails right past it. The fix is hybrid search. Run vector search and traditional keyword search together, then fuse the rankings. Azure AI Search does this for you. On top of that, turn on semantic ranking, which rescores the top results with a deeper model and can pull the genuinely best passage up from position 8 to position 1. Hybrid plus semantic ranking is, in my experience, the single biggest quality lever you have, and it's mostly configuration, not code. Here's the query path in Python with the Azure SDK. You build a vectorized query from the user's question. Hand it to the search client with a keyword query string for the hybrid part. Request semantic ranking and ask for the top 5 results. Then you concatenate those chunks into the system prompt and call the chat completions endpoint. The key detail: cap the number of chunks. More context is not better. 5 tight, relevant chunks beat 20 loose ones, and they cost less per call. For things bite people. First, grounding discipline. Instruct the model to answer only from the provided context and to say it doesn't know otherwise, or it will happily fall back on training data. Second, stale indexes. When documents change, you must rechunk and re-embed. Set up an indexer or a refresh job. Third, security trimming. If users have different permissions, filter results by an access field in the index, because the model will leak anything you retrieve. Fourth, cost and latency. Embeddings, search, and generation are 3 separate build calls per question, so cache embeddings and watch your token counts. So, the takeaway: RAG quality is a retrieval problem, not a model problem. Get chunking and metadata right. Use hybrid search with semantic ranking. Cap your context. and force the model to ground its answers. If you do one thing today, enable semantic ranking on your existing index and compare answers side by side. It's the highest return for the least effort. Pricing, model names, and semantic ranking tiers change often, so check the current Azure docs before you commit. Build the retrieval well, and the language model finally looks as smart as the demos promised. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.